This PowerPoint is to cover section 3.1, the basics of function and function notation. So first of all a relation is just a relationship between two things. For example, test 1 and your score on test 1. You should say you have an ordered pair 1, 70. That would mean that test number 1 you made a 70. But not all relations are functions. For example, if I had 1, 70 and then 1, 80, it kind of wouldn't make sense because on test number 1, I'm supposed to make the same grade, right? I can't make two different grades on the same test. So that would be a relation to write those two ordered pairs, but not a function, because a function is very specific. For one input, you need to get a specific output. On the other hand, let's say I had 1, 70 and 2, 70. Now that is a possibility. So it is okay to repeat the second value, what we think of as the y value, but not the first value. So in this example, we have two relations that are written as ordered pairs, and you can see the graph down below. So for relation 1, we have the ordered pair 2, -1, 1, 3, 1, 4, and 3, -1. Is this a function? Well, we already said that if we repeat the same first element with a different second element, that may be a relation, but it is not a function. So this one is not a function. Why is it not a function? Because for this one value of x, we mapped it to two different values of y. Let's take a look at the second relation. We have -2, 1, 1, 3, 2, 3, and 3, -1. Now this one, we did not repeat any of the first elements, any of the x values, so we really don't have to worry about it. We could repeat the first element and write another ordered pair 3, -1. It would be kind of superfluous. It's the same point. We wouldn't typically do it. However, it still would be a function because for the same value of 3 for x, we get the same value of -1 for y. So that one, no matter what, it is a function. Now, we're going to go on to thinking about it in a visual, graphical way. So if we look at that first one, what made this not a function were these 2 points that have the same x value of 1, and we went through two different y values. This one says this one fails the vertical line test. So it is not a function. For one x value, it had two y values. It crossed through more than one point for that vertical line, x is equal to 1. For the next one, no matter where we draw a vertical line, it crosses through at most 1 point, sometimes no points. So that one passes the vertical line test, and it is a function. So here we have the visual of it. The first one is a function because no matter where you draw that vertical line, it passes through at most 1 point. The next one is not a function because we can find a place where it passes through more than 1 point. Notice that we could also have written a vertical line here that only goes to that 1 point, but if we can find any line anywhere that passes through more than 1 point, it is not a function. So this is for you to try. Please pause and I'll go over the answer just a moment. In this first one, it fails the vertical line test. It is not a function. The second one, no matter where we draw a vertical line, it passes through at most 1 point, so this one is a function. The next thing we're going to look at is function notation. Please don't be confused by this. Really, if you see f of x, it just means we have y, because y is a function of x. Right? So you're used to seeing something like this, y equals 3x plus 2. If we substituted a value in for x, let's just say we put a 5 in there. We could say y equals 3 times 5 plus 2. That would give us 17, right? And we could write that as an ordered pair. We could say that when our input for x was 5, our output for y was 17, and we could graph that point and eventually graph that line. All we're going to do now is that rather than saying find the value of y when x is equal to 5, we're just going to say find f of 5. So this y is a function of x. All we're going to do is put notation for all those words. Find the y value when x is equal to 5. Much simpler. So what we say is that our independent variable is what we're putting in. This is our input, our independent variable. And then our output is our dependent variable. It depends on the value of the x. All right, so to evaluate, I don't know why we have solve functions here. We're evaluating functions. There's no equation here. All we have is the function, and we want to evaluate by finding the value of f of 2. That tells you that my x value is 2, and I want to find the value of the function when x is equal to 2. We simply replace the x's with the number 2. You can see we replaced this x with a 2, this x with a 2, this x with a 2, and then you simplify using your order of operations. So of course we have to do exponents first. That would give us 4, multiplication plus 6, and then addition and subtraction. When we add all those together, we end up with 6. If we'd like, we could write that as an ordered pair. X was 2, y was 6. So when you substitute, it is a good idea to use parentheses when you substitute your x value. So please try these. If you would like, pause this video and then come back for the answer. I'm going to go over them now. So for f of 0, we would write the opposite of 0 squared minus 3 times 0 plus 1. Using our order of operations, 0 squared would be 0. Negative 0, or the opposite of 0, would still be 0. This is equal to 0 minus 0 plus 1, which is equal to 1. Now, ordinarily our form would say that we'd write this equals 1 just below those equal signs, but I'm kind of out of space. If you wanted to, you could also write this as an ordered pair, 0 for x, 1 for your f of x or y. Let's find f of 2. Once again, we're going to substitute 2 in place of the x. Notice that I'm putting parentheses when I substitute those values. Helps me with my order of operations. So for the first one, notice I'm squaring 2, not negative 2. So 2 squared is 4. The opposite of that is negative 4. Minus 6 plus 1, and that gives us negative 9. Once again, 2 was the x value, negative 9 is the y value. Finally, we're going to look at f of negative 3. We'd have the opposite of negative 3 squared minus 3 times negative 3 plus 1. This is where your parentheses are really important, because we notice here that we first have to square negative 3. That gives us positive 9. But when we multiply that then by this negative sign outside, we end up with negative 9 plus 9 plus 1, which gives us 1. And once again, you could write this as an ordered pair. X was negative 3 and y is 1. The next thing we're going to review is set builder notation. I think the picture is the best way to look at it, right? So you guys are already accustomed to inequalities and writing inequalities. The set builder notation just adds some fancy stuff around it, right? And what we read this as is the set of all. That's what that bracket right there means, the set of all. We define our variable h. We read this as such that, and then we state our rule. This is our rule, okay? So looking at the picture, it says that h is between 5 and 10. So here we have 5, here we have 10. H would be all the values in between those two numbers. Notice that we do not include the value at 5, so we have an open circle there. And we do include the value at 10, so we have a closed circle there. Notice for your interval notation that if we want to include it, we want it to be equal to, we use a bracket. If we don't want to include it, we use a parenthesis. So the parenthesis goes up to, but does not include that point. So here we also could have written this as 5 to 10 in our graphical representation, but definitely for our interval notation, if it's included, we use the bracket. and if it's not included, we use our parenthesis. That's if you have strictly greater than or less than. All right, let's look at the next one. It should be fairly simple. Notice in this case, we're including the left-hand side, but not the right-hand side. So in this case, this is not correct. So we would have the bracket on the left-hand side and the parenthesis should be on the right-hand side. Glad we did this. We corrected this problem. In the next one, you'll notice that both sides are open because neither 5 nor 10 is included. And we're missing something here. This should be 5 is less than h is less than 10. And notice also that we've got parentheses on both sides. The next one simply says that h is less than 10, which means we're starting at 10 and then we're going to the left. Notice in this case, the left points toward negative infinity. You can never ever reach infinity, so infinity symbols are always going to have a parenthesis. We also are not including the endpoint at 10, so we have that parenthesis there. In the next example, it says greater than or equal to 10, so here's equal to 10. Greater than would be pointing to the right, that's pointing toward positive infinity. Once again, we have a bracket to show we want to include, the parenthesis because we can never reach infinity. If our solution is all real numbers, that means everything on the number line. This is a funny little symbol for all real numbers. Our interval notation would be from negative infinity to positive infinity. Notice that both sides get a parenthesis. Okay. So you do need to know the basics of a few graph shapes. So we need to know the name of it, the basic graph and its shape, and be able to identify the domain and range, and especially that x or y intercept. Okay. So the constant function just looks like y is equal to a constant, or remember our function notation, f of x is equal to a constant, which means no matter what the value of x, right? So if x is 1, we get 2. If x is 2, we get 2. If x is 3, we get 2. If x is 1/2, we get 2. No matter the value of x, we still get that same value of c for y. Notice our domain can be any x value from negative infinity to positive infinity. Any real number will do. The range, well, it's just that one value, so it's just c. Identity function is just y is equal to x. So y takes on any value that x is. So when x is 1, y is 1. When x is 2, y is 2. When x is 1.5, y is 1.5, and so on. The domain is all reals. The range is all reals. There are no restrictions on this domain and range. Well, for the next one, we have our absolute value function. Notice that beautiful V shape when you graph your absolute value function. You can see a couple of values have been substituted here. Notice that if we have a negative value for x, because it's absolute value, it changes it back to positive, and that's why we have that flip up on that left-hand side at the 0. Notice your x-intercept starts here at 0, 0. That's a very important point. Our domain is from negative infinity to positive infinity. Notice for your range, nothing dips below this line right here. Everything is above the line, right? So our y values start at 0, including the 0, and go toward infinity for our y values. Here we have a quadratic function. We recognize it from this squared right here. We have a graph showing some substitutions, and you can pause for a moment and see where they all came from if you'd like. Our domain in this case, as you can see, no matter what the value of x is, even over here at negative 10, let's just say. We go up here somewhere, there's going to be something on that graph because it continues to go up and out. So our domain is all reals. Our range, if you notice again, our lowest value is here at 0, 0. We include it, and our y values go up to positive infinity. This one's special. We have a square root function. Notice this one does not include any values on the left-hand side of 0 for x. That's why our domain starts here at 0 and goes toward infinity for our values of x. Why is that? Well, let's say we substituted -1 for x. Let's say we broke the rules and we wanted to find the square root of -1. Well, that is not a real number. We cannot graph that. As a matter of fact, when you take the square root of a number, you know that that number has to be at least 0. So our domain is from 0 to infinity for x. Our range, if you notice again, it starts here at 0, 0. Our y values go to infinity. Cubic function. Again, no restrictions on your x. You can see no matter where your x value is, even here, you're going to have some value down there because that keeps going down and widening out. This one keeps going up and widening out. We're going to have any x value included on this graph eventually. Also for our range, there are no restrictions, -infinity to +infinity. Cube root function, we're not going to focus on too much, but if you'd like to pause and take a look, you may. We're not going to focus much on reciprocal functions right now either, or definitely reciprocal squares functions. Okay, so what is the difference between a relation and a function? A relation is any old pairing of two things, right? A function is very specific. For one x value, for one input, we have only one output. How do you evaluate a function? All you have to do is substitute that number into every place you see it in the function, right? And simplify. What's the general shape of a quadratic function? That one we're going to hit a lot. It looks like that cup shape. Okay. Sometimes you're going to see it points downward instead, but that's special. We're going to worry about that later. Okay, but it has that cup shape. What is the difference between brackets and parentheses? In interval notation, the brackets include the value. So it could be for less than or equal to or greater than or equal to. The parentheses do not include that endpoint. What is the range of a square root function? Remember, the domain is going to go from 0 to infinity. The range is going to go from 0 to infinity. Piecewise functions, we've not really looked at those, but if we did have a piecewise function, we'd have a rule for each piece based on some kind of domain. For example, let's say it was x plus 3 for x is less than 0, and x minus 3 for x is greater than or equal to 0. So if we had a value like 5, we pick our domain that it fits into first. 5 is greater than 0, so we'd substitute it into this piece of the function. Notice we could not substitute it into both pieces because for one input value, we should only get one output value. If we substitute it into the other one, we'd get an 8 instead of a 2, and we can only have one y value for each x value. That's the end.